Hello everybody and welcome to my tutorial on 7-segment displays for a class that I'm attending at the University of Technology. The class is Robotics 173, Introduction to Microcontrollers. Okay, for this assignment I had to set up a 7-segment display and I had to use 4 buttons to be able to cycle through 0 through 9. And it was difficult at first. The first time I wrote the program, it was doing a lot of sporadic things. For instance, if I pressed 2 buttons at the same time, it would flip-flop between the first 2 states and not the third state that I wanted. So, example, if I press button 1, it would print out a 1. If I press button 2, it would print out a 2. But if I wanted to press button 1 and 2 at the same time and print out a 5, it wouldn't do it, even though I coded it to do it. So the trick was, or the problem was, I was telling the computer to write the 7 segments out individually. And what was happening, I think, my hypothesis is that even though I have pull-up resistors that are doing an excellent job, it was kind of cycling between the 2 states um, because of the code. So what I did is I decided to implement functions, and I put every character that is going to be displayed on the 7-segment display into a function, its own function. So that way, when the function is called, it's called within the scope of an if statement. And as soon as that if statement is executed and the scope is executed, and we leave the scope, basically, the program finishes that part of the function. That function will no longer exist because it is in the scope of that if state, if that makes sense. Otherwise, we were trying to, trick the computer into thinking that we were supposed to be doing 2 and 3 different things at the same time. At least that was my hypothesis. The other thing I did was I put a clear function in that I didn't have to clear the screen basically of the LED. And in conjunction with those 2 working theories, it worked. So, hey, I kind of basically learned something. So let's get into the code and I'll kind of walk you through it. It's actually pretty easy. I don't know why it was stumping me in the end, but it was. So here's what I did. Oops, array is with 2 R's. You didn't see that. Okay, so what I did is I made 2 different arrays. And this one should be constant. Hey, it's a work in progress, right? Okay, so I have 2 constant arrays that are full of integers. The one is going to store the pin locations for the LED segment. Um, and I use pins 2 through 8 to do that. The other one is going to store the pins for the buttons. So I have 4 buttons and I'm using 9 through 12 for that. Um, then I make some functions basically here. And what we did here is each function is going to represent a number, 0 through 9, and one that's going to represent null, and that's clear. So how we did it is in the function, we just digital write to each segment that is in the array here. And we tell it to either be high or low. And with using high and low, we can draw a number. So I did clear 0 through 9. And they worked. They worked great. I'll show you that in a minute. So the next thing we do is we have to set up the program. And I did it this way. This is something new I learned in this class. I use a loop to iterate through the array of LED segments. And I use the loop going through it 7 times for each segment, basically. And we make those outputs. So it's kind of a pretty neat way to set all of the pin modes to outputs without having to write an ungodly amount of code. And whoever thought of this, I thank you very much because I'm going to be using this a lot. So I do the same thing with the buttons. We iterate 4 times through it, incrementing a a plus, or in addition to the number that we're at. Every time we loop through it, we loop through it 4 times, and we set the input, we set the pin mode state to input pull up. This was tripping me out at first. I'm going to be honest with you. I started off using my own pull up resistors. I started with a 10K, um, 10 kilo ohm resistor, and it was having unpredictable effects. So I dropped it down to a 1K. I figured between 10K and 1K, I'd find something in between, right? No, I was having a really hard time with it. So I decided to use the internal pull-up resistors in the Adreno. Uh, it worked. And I think that Adreno's pull-up resistors simulate a 30K resistor. I could be wrong, but I needed a pretty strong resistor to be able to get it to function. That was one of the problems I was having right off the bat. So, knowing that, set everything up correctly, I move into the loop. And the loop basically, it's pretty easy. I have a bunch of if statements. Okay, if you can see, I have a bunch of them and an else statement at the end. So these if statements are really easy. If you're pressing a certain button, it's going to output a certain number. So if button 1 is low, um, because we're using a pull-up resistor, the states are going to be set to high. So I wanted to make sure that the button was pressed in order to get this thing to do what I wanted it to do. So obviously when you're pressing a button from a high state, it's going to go to a low state until that button is not pressed anymore, because these are momentary contact buttons. So that's how that works. So, we have if statements here, checking the states of all of the 4 buttons that are in there. And if it's correct, if you do the correct amount of button presses, if you press 1, you're going to get a 1. If you press 2, you're going to get a 2. And then it gets to where you got to press 2 buttons. And this is where I was having a problem, because of the fact that all of the research I did online pointed to that you can't do 2 buttons, read 2 buttons at the same time simultaneously with Adreno, because it's going to flip flop. And at first I thought, well, we'll just add a debounce, right? No, it didn't work. Well, UAT guys, we proved the worst of the world wrong, because we were able to get this to work. And how we were able to get it to work is by using functions, and by basically hard coding it, saying that we're going to check each button state. It finally worked. It works great now. So I'm able to do all of those things, and I was able to implement a truth table that I made in order to get the right button presses. So the truth table basically went through 4 buttons and a combination of different states to get 1 through 0. And it worked. And then in the end, if no button is pressed, then we call the clear statement, just as a precautionary measure to make sure that there's nothing being displayed on the 7-segment display. So that is that. Now let's take a look at the code in action.
Hey guys, okay, so here's my 7-segment display. I had a little difficulty with this one at first. My code wasn't working right. When I had to do more than 1 button press, it was doing unpredictable things, but I figured out the problem. It was kind of fun. So here we go. Okay, so this is actually an state that I call clear. It's actually running, but because there's nothing being pressed and all of the buttons are set to high, nothing is going to be showing. So there you go. So it goes in succession. If you press button 1, you get a 1. If you press button 2, you get a 2. If you press button 3, you get a 3. If you press button 4, you get a 4. Now, if you press button 1 and 2 together, you get 5. 2 and 3 together, you get 6. 3 and 4 together, you get 7. 1 and 3, you get 8. 2 and 4, you get 9. And 1 and 4, you get 0. So we're able to cycle through the entire spectrum of this 7-segment display using truth tables. And that, my friend, is logic for you. So the one thing that was tripping me up was I didn't have a function written to clear everything out once the buttons were pressed. So that was one of the biggest things that was happening with my code. Anyway, perseverance succeeded, and I was able to complete this assignment. Thank you very much. Have a wonderful day.